Welcome all to the Fundamentals of Electrical and Electronics Engineering, Unit 5, Introduction to Electronic Devices and Digital Electronics, Session 19. Myself, Ranganatha KV, working as a lecturer in Electronics and Communication Engineering Department, Government Polytechnic for Women's, Bengaluru. In this session, the topics to be covered are the PN junction diode symbol, PN junction diode construction, PN junction diode working and its characteristics, as zero bias condition, forward bias condition, reverse bias condition, diode as a switch, types of diodes and its ratings, and the applications of diode. What is a PN junction diode? A PN junction diode is one of the simplest semiconductor devices around and which has a characteristics of passing the current in only one direction. The PN junction diode has two terminals, can be termed as anode and cathode as shown in the symbol. See in the symbol, this is the symbol to represent a diode, so which is having anode with positive sign and the cathode with negative sign. This is the bar to represent the cathode of the diode, which is usually marked by the white line. PN junction diode forward biased conventional. When it is forward biased, the conventional current flows from anode to the cathode indicated by the arrow mark. A PN junction diode is formed by doping one side of a piece of silicon with p-type dopant called boron and the other side with the n-type dopant, that is phosphorus. The terminal connected to the p-type material is called anode and the terminal connected to the n-type material is called cathode. See in the diagram, the p-type and the n-type and the junction formed between the p-type and n-type is called p-n junction. So the PN junction diode working and its characteristics. Biasing is a process of applying external voltage, and zero bias or unbiased when no external voltage is applied to the PN junction diode. Forward bias, the voltage potential is connected positively to the p-type terminal and negatively to the n-type terminal of the diode. And the reverse bias, the voltage potential is connected negatively to the p-type terminal and positively to the n-type terminal of the diode. Now we will see zero bias condition. No external voltage is applied to the PN junction diode. The electrons diffuse to the p side and simultaneously holes diffuse towards the n sides through the junction and then combine with each other. Due to this diffusion of electrons to the p side and holes to the n side, an electric field is generated by the charge carriers. This electric field opposes further diffusion of charge carriers and equilibrium state is reached and no further flow of charge occurs. Just observe in the diagram, I have shown how the electrons diffuse towards the p side and holes diffuse to the n type. See, an electron, movement of electrons and the holes. Where the two areas meet and at equilibrium, there are no free holes or electrons in this region. So when the diffusion happens, electrons move towards the p type and holes move towards the n type. So in both the junction, so no free electrons and no free holes. So that junction is called depletion region as shown in the figure. This is the diffusion layer and this region is called diffusion region. So in this region, no free holes or no free electrons because all the electrons are diffused to the p type and all the holes are diffused to the n type. So in the forward bias condition, the negative terminal of the battery connected to the n-type material and the positive terminal of the battery is connected to the p-type material. Electrons from the n region cross the junction and enters the p region. Due to the attractive force that is generated in the p region, the electrons are attracted and move towards the positive terminal. Simultaneously, the holes are attracted to the negative terminal of the battery. So by the movement of the electrons and holes, the current flows. See how? As I said, the anode or the P type is connected to the positive terminal and N type is connected to the negative terminal of the battery. And the electrons move and the holes also move. So this, because of this movement of electrons in the holes, the current flows in the circuit. And the reverse bias. The P type is connected to the negative terminal while the N type is connected to the positive terminal of the external voltage. So majority charge carriers are attracted away from the depletion layer by their respective battery terminals. So as a result of the width, the potential barrier increases that impedes the flow of majority carriers in N side and P side. There will be no recombination of majority carriers taken place at the PN junction, thus no conduction of electric current. The current that flows in the PN junction diode is a small leakage current in microamperes due to the minority carriers which drift across the PN junction. If the reverse bias voltage VR applied to the diode is increased to a sufficiently high value, it will cause the diode's PN junction to overheat and fail due to the avalanche effect. See, as I said, the P type of the junction PN junction diode is connected to the negative terminal of the battery, and the N type of the PN junction diode is connected to the positive terminal of the battery. Hence, it is connected in reverse bias. So, as a definition of the PN junction diode, so it conducts only in one direction, that is from forward bias condition. So P type should be connected to the positive terminal of the battery and N type should be connected to the negative terminal of the battery. So only in forward bias condition the diode conducts, and in the reverse bias condition the diode does not conduct. So VI characteristics of the diode. VI characteristics are nothing but the graph between the voltage and the current obtained when the current is measured through an electronic component as the voltage is applied across it. By supplying the voltage, positive voltage, the electrons and the holes get enough energy to overcome the potential barrier or the depletion layer and cross the junction. The amount of energy required by the electrons and the holes for crossing the junction is equal to the barrier potential, 0.3 volt for germanium and 0.7 volt for silicon diode. See, this is the diagram of the circuit for forward bias, and this is the circuit for reverse bias. Just see, the positive terminal of the battery has been connected to the positive terminal of the diode, and the negative terminal of the battery connected to the negative terminal of the diode, and where this is the multimeter connected to measure the current flowing through the circuit, and this is the voltmeter connected to measure the voltage across the circuit across the diode. And here, since in this the circuit is forward biased, so the current, since the current flows, we can measure the current as well as the voltage. But here, since the diode is connected in the reverse bias and the diode does not conduct in the reverse bias, so no voltage, no current flows, and no voltage can be measured across in the reverse bias condition. Forward bias characteristics. When the diode is in forward bias, the current increases slowly and the curve obtained is non-linear as the voltage applied to the diode is overcoming the potential barrier. Once the potential barrier is overcome by the diode behaves normal and curve rises sharply as the external voltage increases and the curve so obtained is linear. See in the graph, so in the y-axis the current is taken and the x-axis the voltage is taken, and up to this point the voltage 0.7 volts. Up to this the curve is non-linear, and this is a threshold point. So once the diode crosses the junction with the threshold voltage, so it overcomes the potential barrier and it increases linearly. So this is the forward biased characteristics. The reverse bias characteristics. Due to the movement of minority carriers, a very little current flows reverse saturation current. You call it as reverse saturation current. When the reverse voltage is increased beyond the limit, then the reverse current increases drastically due to diode breakdown. So avalanche breakdown and general breakdown, those effects will happen, and this is where once it crosses the limit, this is the breakdown voltage limit. Once it crosses the breakdown voltage, I mean the limit of the voltage 0.7 volt for silicon or 0.3 volt for germanium. So the current drastically increases in the reverse direction. This is the characteristics of a diode in reverse bias. Now see how the diode works as a switch. The PN junction diode allows current only in one direction when it is in forward bias mode, acts as a closed circuit. The reverse bias mode acts as open circuit as there is no flow of current in this mode. In the reverse bias mode, as I said, the diode conducts only in one direction, that is in forward bias mode, and in reverse bias mode it acts as an open circuit because the diode will not conduct and no current flows to the mode. Hence the change of forward and reverse bias states makes the diode work as a switch, for forward being on and for reverse being off. So you see this is the diagram which shows how a diode can be working as a switch. So this is the closed circuit, the closed switch when the diode is in forward bias mode, and this is the reverse bias switch when the diode is in reverse bias mode, that is open circuit, and this is the closed circuit. What are the different types of diodes and its ratings? We'll see now. We have different types of diodes, basically namely PN junction diode, Zener diode, tunnel diode, photodiode, Schottky diode, varactor diode, and light emitting diode. We shortly will call it as LED. What are the diode ratings? Breakdown voltage, it has PIV, will call it as peak inverse voltage or PRV, and the voltage at which the avalanche occurs, diode is destroyed if this rating is exceeded. That is, the diode is having a voltage limit. Once it crosses the voltage limit, the breakdown voltage, and it destroys the diode. Average forward current, we will call it as I naught. It is the maximum allowable average current. Maximum forward surge current, IFSM, we will call it as. It is the maximum instantaneous current. The maximum reverse current, we will call it as IR. It is the maximum reverse current. What are the applications of diode and where you can use the diode? PN junction forward bias condition is used in all LED lighting applications. See, in LED, it is acting as a, since the diode is acting as a switch, so we can use it in LED applications. The voltage across the PN junction bias is used to create temperature sensors and reference voltages. It is used in many circuits like rectifiers, varactors for voltage controlled oscillators. It is used as rectifiers in DC power supply manufacturing. It is used as switches in digital logic circuits. It can also be used as a solar panel. See how we can use the diodes in the solar panels. Some questions we'll see now on what the topic we have covered so far. First one, when PN junction is in forward bias, by increasing the battery voltage. So it can be a circuit resistance increases, the current through PN junction increases, the current through PN junction decreases, and none of the above. The answer is current through PN junction increases. That is, when the PN junction is in forward bias, by increasing the battery voltage, the current through PN junction increases. Second question, when the diode is reverse biased, it is equivalent to an off switch. An off switch. The options are an off switch, an on switch, zero, and none of the above. So the answer is an off switch. Because the diode, when it is in reverse biased, it will act as an open circuit and no current flows through. So it can be called as an off mode. So the answer is an off switch. Third question, the knee voltage or the cut-in voltage of SI diode is approximately. Options are 0.2 volt, 0.7 volt, 0.8 volt, and 1.0 volt. So the answer is the cutoff voltage of a diode, the silicon diode, is 0.7 volt. The option 2 is the answer. 0.7 volt. Question number 4. The PN junction diode is used as an amplifier, a rectifier, an oscillator, and a modulator. So this is an application of a PN junction diode where we can use. So the PN junction diode is used as a rectifier. So option 2 is the answer, a rectifier. Question number 5. So how many junctions do a diode have? So options are 0, 1, 2, and 3. How many junctions do a diode have? It has only one junction, that is called PN junction. So the answer is 1. Question number 6. A PN junction diode has dash electrodes. That means a PN junction diode terminals. So how many terminals the PN junction diode is having? 2 terminals, anode and cathode. That can be called as electrodes. We can call it as electrodes. So the answer is 2. So option 3, 2 is the answer. That is, the PN junction diode has 2 electrodes. What are the 2 electrodes? Anode and cathode. Question number 7. When a PN junction is reverse biased, holes and electrons tend to concentrate towards the junction. The barrier the barrier tends to break down. Holes and electrons tend to move away from the junction. None of the above. So when the PN junction is reverse biased, the holes and electrons tend to concentrate towards the junction, or the holes and electrons tend to move away from the junction, because when the electrons and the holes are moving away from the junction and they will not combine together and no current flows. When the no current flows in the reverse bias condition, the diode will not conduct. When the diode will not conduct, it will be in off state. So electrons and the holes will move away from the junction. So the answer is option number 3. Holes and electrons tend to move away from the junction. Question number 8. As a PN junction is forward biased, when the PN junction is forward biased, holes as well as the electrons tend to drift away from the junction. The depletion region decreases. The barrier tends to break down. None of the above. So when the PN junction is in forward biased, the depletion region decreases, because the electrons and the holes move together and the current flows. Because of the movement of those electrons, the current flows. When the current is flowing, the diode will conduct. So when the diode is in conduct, so it will be in on mode. So and the depletion region will decreases. So the answer is option number 2. The depletion region decreases. Question number 9. The arrow direction in the diode symbol indicates the direction of electron flow, direction of hole flow, opposite to the direction of hole flow, none of the above. So the arrow direction in the diode symbol indicates the direction of hole flow. So the answer is direction of hole flow, option number 2. Question number 10. Dash is the process of applying an external voltage to the diode. So it is biasing. Biasing is the process of applying the external voltage to the diode. So the answer for the question number 10 is 1. Biasing. Thank you. And the LMS e-content team members are myself, Sri Ranganatha KV, e-content developer, Government Polytechnic for Women, Bengaluru. Shri Prashant, e-content developer, Government Polytechnic, Devadurga. Srimati Shanta C. Mukherjee Hall, course expert, Government Polytechnic for Women, Bengaluru. And Shri Wajid Ahmad, course moderator, Government Polytechnic, Immadihalli, Bengaluru.